Welcome to the video lectures of Marzan tutorials. Today we'll be doing a question based on AC circuits. Okay, the entire question is explain root mean square value RMS value of alternating signal and hence derive the relation between RMS value and peak value of alternating signals. Then derive an expression for the heat produced by an alternating current. Okay, so this entire question is divided into three parts. First, explain root mean square value of alternating signal. Okay, so first explain what? Explain IRMS. Okay, this is the first part. Then derive the relation between IRMS value and the peak value, okay, of the alternating signal. Okay, so second part is what? Second part is relation between IRMS and I0. What is this I0? This I0 is the peak value. Okay, and third part, derive an expression for the heat produced by an alternating current. So we have to find the formula for heat. Okay, so this entire question is having three different sub questions. So I hope the doubts are clear. Okay, you understood the question first of all. Okay, now first let us go to the first part, explain IRMS. Okay, now what is the meaning of IRMS? Okay, now remember this one thing, I0 the peak value, IRMS is what? IRMS is a DC current. It is what? It is a DC current. Now what is the meaning of that? Okay, so first of all we are having this circuit. Okay, in this circuit an AC source is applied and this AC source is supplying a particular current to resistance R. Okay, so this is a typical AC circuit. So IRMS is what? IRMS is that DC current. It is that DC current which when passes through the same resistance, which when passes through the same resistance produces the same heat. It means what? Suppose I'm having this AC circuit and this AC circuit is producing a certain amount of heat in this resistance box. Okay, now I am having what? Now I am using the same resistance R and I have connected it to what? To a DC source. Now this DC source is supplying a particular current and this resistance is producing same heat in this circuit, and in this circuit the heat is what? The heat is same. So I will say this is what? This is IRMS of this circuit. This is the RMS value of this AC current. Okay, so remember IRMS is not AC, IRMS is DC. So IRMS is that DC current. It is that DC current which when passes through the same resistance will produce the same amount of heat. Okay, same amount of heat when AC current is passing. So it doesn't matter if I have this resistance. In this resistance if I pass AC current or RMS value of this AC current which is DC, it will produce the same heat. Inside the resistance. Okay, so if I am passing the AC current or if I am passing the RMS value of the AC current which is DC current, it will produce the same amount of heat. Okay, now the formula for IRMS. Okay, you have to remember the formula for IRMS. Mathematically I can say that IRMS square is equal to integration for one entire cycle. The maximum angular displacement is 2 pi, so 0 to 2 pi I square dot d theta upon 2 pi. Okay, this is the mathematical formula for IRMS. Remember this formula. Okay, it will not be given in the examination. You will have to know this formula beforehand. Okay, fine. So we have done the first part. Okay, first part, IRMS is what? It is the DC current which when passes through the resistance produces the same amount of heat as the AC current. Okay, now next is what we have to now prove, relation between IRMS and I0. Relation between IRMS and I0. Okay, now how will we do that? For that we'll be using this mathematical formula. For that we'll be using this formula. Okay, so let us start from this. IRMS is equal to integration of 0 to 2 pi I square dot d theta upon 2 pi. That's the formula. Okay, now the formula for I is equal to how much? I is equal to I0 sine theta. I hope you remember this formula. Okay, so in place of this I square I will put what? I square is equal to I0 square sine square theta, squaring both the sides. Okay, so IRMS is equal to, I'll take this 2 pi outside, constant 1 upon 2 pi integration 0 to 2 pi I0 square sine square theta dot d theta. Okay, now this I0 is also constant. It is what? It is the peak value, so we can take it outside. So this will become how much? It will become I0 square upon 2 pi integration of sine square theta dot d theta 0 to 2 pi. Okay, fine. So now for solving the sine square ka integration, we'll be using the double angle formula. Okay, now what is the double angle formula? The double angle formula states that 1 minus cos 2 theta is equal to 2 sine square theta. Now we have done this formula in logbook many a times. Okay, so I hope you remember this formula. So keep this 2 on this side, so it will become 1 minus cos 2 theta upon 2 is equal to sine square theta. Understood? Fine. So in place of the sine square theta, I will put what? I'll put 1 minus cos 2 theta upon 2. Okay, so this equation will become what? This equation will become, this is equal to I0 square upon 2 pi integration of 0 to 2 pi 1 minus cos 2 theta upon 2 dot d theta. Understood? So we have reached over here. Okay, now a little bit mathematical solving is still left. Okay, so this 2 will be taken outside. Already we have 2 over here. It will become what? I0 square 2 into 2 pi integration of integration of 1 minus cos 2 theta dot d theta. Okay, so let us solve this integration separately. I will solve this thing separately, so you will be able to understand that how this integration is being done. Actually, if you don't even mention it in examination, it will be okay, but just to show you the solving of this thing. Okay, so I will say what? Now let us assume that we are having 0 to 2 pi 1 minus cos 2 theta dot d theta. Understood? So I will open the integration. It will become how much? It will become integration of 0 to 2 pi 1 dot d theta minus 0 to 2 pi cos 2 theta dot d theta. Okay, now integration of 1 is how much? Integration of 1 is x. So with respect to d theta, it is how much? It is only theta. Theta 0 to 2 pi, upper limit and lower limit. Okay, minus integration of cos 2 theta is how much? Integration of cos 2 theta is sine 2 theta, and whatever is the coefficient of theta, that will get divided. For integration, whatever is the coefficient of x, that will get divided. We have done this formula many times. Okay, so this 2 theta ka 2 will get divided. Okay, upper limit is 2 pi, lower limit is 0. Okay, now what we do is that we do upper limit minus lower limit, है ना? So in place of theta, first I'll be having 2 pi minus 0 minus, and then in place of this thing, what do you say, sine 2 theta, in place of this theta, first I will be having 2 pi and then I will be having 0. So hence it will become sine 2 into 2 pi upon 2 minus sine 2 into 0 upon 2. Understood? Now 2 pi minus 0 will be how much? 2 pi minus 0 is 2 pi only. Okay, 2 pi minus. Now the value for sine 2 pi and any multiple of sine 2 pi, the value for sine and 2 pi, any multiple of 2 pi will be how much? It will be equal to 0. This is also how much? This is also 0. So I will say 2 pi minus 0 minus 0. So hence the final value is how much? It is just 2 pi. Okay, fine, understood. The final value is how much? It is just 2 pi. Okay, so we'll be substituting this value 2 pi in the previous solving. In the previous solving, it will become I0 square upon 2 into 2 pi into 2 pi. The answer is what? Answer is 2 pi na. So I'll put over here 2 pi. 2 pi, 2 pi is cancelled. What is left? I0 square upon 2. So hence I will say that as r.m.s square is equal to I0 square upon 2, taking square root on both the sides, it will become r.m.s is equal to I0 upon root 2. I have got this equation by taking square root from this equation. Understood? Fine. Now I can say that 1 upon root 2 is equal to, it is equal to 0.707. Okay, so hence I can say that I'll just put a small section over here. I r.m.s is equal to I0 upon root 2, and 1 upon root 2 is how much? 1 upon root 2 is 0.707. So therefore IRMS is equal to, it is equal to 0.707 I0. This is the final formula for IRMS. Okay, fine. Similarly, I can also say that E0 is equal to same 0.707. ERMS is 0.707 of E0. Okay, remember this formula. Okay, so we have now got the relation between IRMS and I0. So we have done the second part also, relation between IRMS and I0. Now the third part is left, last part is left, heat. Okay, now how will we solve heat? Okay, now in the lower classes we have done that the formula for heat is equal to how much? Heat is equal to I square RT. We have done this formula in 10th standard, I guess. Okay, now for one particular cycle, for one entire AC wavecar cycle, I can say initially the time is how much? Initially the time is 0, and finally the time period T is equal to how much? It is equal to 2 pi by omega. This is the formula for time period, remember. Okay, so in one entire cycle, I can say the average heat produced is how much? Lower limit of time is 0, upper limit of time is 2 pi by omega I square R. Now because you have taken limits of time, hence time T will become dt. Understood? Fine. So once we get this equation, now we have to solve this thing. Okay, fine. R is constant, it will be taken outside. R integration 0 2 pi by omega I square dot dt. Understood? Now the value for I is equal to how much? The value for I is equal to I0 sine theta. So therefore I square will be I0 square sine square theta. So in place of this I square I will put this. Okay, this is equal to R integration of 0 to 2 pi by omega 0 to 2 pi by omega I0 square sine square theta is what? Theta is omega t. So in place of theta I can write omega t dot dt. Okay, now again this solving is not given, but still I'm showing you so that you are able to understand how to solve this thing. Let us see separately. This I0 square is also constant. This is equal to R into I0 square integration of 0 to 2 pi by omega sine square omega t dot dt. Okay, so let us solve this thing. Okay, so I am solving this part separately. I am solving this part separately. Okay, so it will become what? It will become integration of 0 2 pi by omega is how much? 2 pi by omega is t. 2 pi by omega is t. 0 to t sine square omega t dot dt. Okay, now we have done this previously. Sine square omega t will be how much? It will be 0 to t 1 minus cos 2 theta 1 minus cos 2 theta upon 2 dot dt. We have done this previously. Okay, now I can take this 2 common outside. This will become 1 upon 2 integration of 0 to t 1 dot dt minus this entire thing is in bracket. Integration 0 to t cos 2 theta dot dt. Understood? This 2 is common for both of them. Okay, fine. So this will become how much? This will become half. Integration of 1 is how much? Integration of 1 is just capital T. Integration of 1 is just capital T minus integration of cos 2 theta is how much? Integration of cos 2 theta is sin 2 theta. Okay, but the coefficient of 2 will get divided. Okay, so it will become sin 2 theta upon 2. Okay, lower limit is 0, upper limit is t. Understood? Fine. So I'll take a new page for this. So therefore this will be how much? When I substitute the upper limit and lower limit, in place of this t I will be having t minus 0. T minus 0 will be t only. Okay, and then we'll be having sorry, let me take a new page. So hence we are having what? This is equal to half. This is equal to half t minus sine 2 theta. 2 theta, theta is omega t, sine 2 omega t upon 2 omega. Whatever is the coefficient of t, that will get divided. So the coefficient of t is how much? 2 omega. 2 omega will get divided. Upper limit is t, lower limit is 0. This will be how much? This will be equal to half. In place of this t, I'll be having upper limit minus lower limit. So hence I'll be having what? T minus 0 minus, in place of this t I'll be having this t, and then in place of this t I'll be having 0 sine 2 omega capital T upon 2 omega 2 omega sorry omega minus sine 2 omega 0 upon 2 omega. Okay, something like this. This is equal to how much? Half. T minus 0 is how much? T minus 0 is T only. Okay, doesn't matter. T minus 0 is T only. Minus sine 2 omega. What is the formula for capital T? Capital T का formula है कैपिटल टी का फार्मूला है हमने जस्ट थोड़ी देर पहले देखे थे. कैपिटल का फार्मूला है 2 पाई बाई ओमेगा. कैपिटल टी का फार्मूला क्या है? 2 पाई बाई ओमेगा. 2 पाई बाई ओमेगा अपॉन 2 omega, and this entire thing we are having 0 over here. So 0 into 2 omega is 0, 0 upon 2 omega is sine 0 is 0. This entire thing will become 0, so there is no need to write this thing again. Okay, now omega is cancelled. Sine 2 into 2 pi. Okay, sine 2 pi is 0. Multiple of any 2 into 2 pi will also be how much? 0. So this entire part will get cancelled. So what is left? It is just half into t, or I can say t by 2. Understood? Fine. So hence I can say that the final formula became what? The final formula is r I0 square integration of this thing. Integration of this thing is how much it is? T by 2. So r I0 square t by 2. Hence I can say that the formula will be equal to how much? H will be equal to I0 square r into t by 2. Understood? Fine. Now the formula for t is equal to how much? T is 2 pi by omega. So I0 square r upon 2 into 2 pi by omega. Okay, fine. Now I can say that this 2 will get cancelled. This 2 will get cancelled, and after cancelling out I can say the final value is how much? It is r I0 square I0 square pi by omega. I can say the final value is how much it is? I0 square. There is also 1.2 over here. Okay, I forgot to mention this 2. This 2 is still over there. Okay, so it will become I0 square 2 pi by omega. That is the final value for heat. Understood? Okay, fine. So hence we have done the entire derivation. Okay, thank you so much.